Why did my teacher ask that question? What did he mean? That time might not move the same for everyone? That the universe doesn't have a single clock? Time always seems steady, predictable, simple, every second the same for everyone. Was that feeling wrong? What does this all mean?
People had always trusted the clock of nature, but one man wanted to know why the planets never wavered. Night after night he studied their motion, searching for the hidden rhythm behind the universe. From careful observation, he imagined time as a perfect clock, one that ticked the same for everyone, everywhere. Each second passed steadily, each hour followed predictably. If time had a constant rhythm, the motion of planets could be calculated, machines could be synchronized, and the world could finally be measured with certainty. Time was no longer just a feeling, it was a universal order. Newton called it absolute time. For centuries, his idea held. Time flowed steadily, the same for everyone, everywhere. It explained the heavens, the earth, and the life of people on it. It was a rhythm the universe could rely on, a clock that never slipped, never questioned, never wrong.
What would I see if I could run beside a beam of light? Would it freeze beside me, or would it still race ahead?
No matter how hard he tried, he could not make light obey Newton's rules. He imagined chasing light across the universe, and every time, the answer was the same. Even if he moved at incredible speed, light would still move away from him at exactly the same speed.
If light would not change, then something else had to. Is it time? Yes, time is not absolute. It is not the same for everyone. It could stretch, it could slow down.
His theory was not philosophy, it was mathematics. Imagine a train moving at incredible speed. Inside, a beam of light bounces between two mirrors. To someone inside the train, the light moves straight up and down. But to someone standing outside, the train is moving, so the light does not travel straight, it moves diagonally, tracing a longer path. And light's speed cannot change, so if the path is longer, but the speed is the same, the only thing that can change is time. To the moving observer, time itself slows down. The faster you move, the slower your clock ticks. And this isn't just theory. We can see it happening in the real world. Astronauts traveling at high speeds age slightly slower than people on Earth. When planes carrying atomic clocks land, their time is no longer perfectly synchronized with clocks on the ground. Even the satellites guiding your GPS must correct for Einstein's equations. Without those corrections, your location would drift by kilometers in a single day. Time is not fixed. It bends with motion. But motion was only part of the story. Einstein realized something even stranger. Gravity could also change time. Mass bends the fabric of space-time itself. Planets move the way they do because they follow the curves of this invisible geometry. And when space-time bends, time bends with it. A clock near a massive object ticks more slowly than one farther away. Near a planet, time slows. Near a star, it slows even more. Near a black hole, time nearly stops. But Einstein's ideas led to an even deeper realization. Space and time were not separate things. They were part of the same structure, space-time. In this structure, every event has a position, not just in space, but in time. Your birth, this moment, events that have not yet happened, all of them exist somewhere in the fabric of space-time. This led some physicists to a radical idea. The universe may not be flowing through time at all. Instead, the universe may exist as a vast, four-dimensional structure, a block, where past, present, and future all exist together. What we call now may only be a small slice of that structure. Time may not be something that moves forward. It may be something we move through.